This video is going to go over Chapter 6, Section 3, Dividing Polynomials. We're going to look at synthetic division. And so to divide by a linear factor, you can use a simplified process that is known as synthetic division. In this process, you omit all variables and exponents. By reversing the sign in the divisor, you can add throughout the process instead of subtracting. So we are going to take this expression, x cubed plus 4x squared plus x minus 6, and divide it by x plus 1. Starting by reversing the sign of the divisor, making that negative 1, kind of like we would find the 0. Now we're going to take the coefficients of each of these terms. We get 1, 4, 1, and negative 6. Leave a little space for part of this process. The first step of this process is to drop that first coefficient down as 1. And now we begin a process of multiplying the divisor times any of the answers down below. So negative 1 times 1, negative 1. And then we add 4 minus 1, which is 3. Take that, multiply again, gives us negative 3. Adding, negative 2. Multiplying, positive 2, gives us a negative 4. The last number here is our remainder, and we rewrite this by dropping one exponent down. So we get to x squared plus 3x minus 2 with the remainder of negative 4. Looking at another example, using synthetic division to do the same thing. X plus 2 is the divisor, so it's negative 2. We reverse the sign. 1, negative 2, negative 5, and 6. Synthetic division again, drop the first one. Negative 2 times 1 is negative 2. Adding that together gives us negative 4. Multiplying negative 2 times negative 4 gives us a positive 8. Adding those is 3. 2 times negative 2 is a negative 6. Adding those together gives us a 0, meaning we have a remainder of 0, which means that x plus 2 is a factor of that cubic expression. So we rewrite this as x squared minus 4x plus 3. Part of that expression now is still x plus 2, and these are the two factors that we have. We also want to completely factor this, and we know how to factor this trinomial without synthetic division or long division. Because this is minus and this is plus, we know they're both negative. The only factors of 3 are 3 and 1. So the completely factored version of that would be the quantity of x plus 2 times the quantity of x minus 3 times the quantity of x minus 1. There is also a remainder theorem that says that we can find p of x of any degree polynomial that has a degree that is higher than 1 or equal to 1, and divide it by the factor x minus a, where a is the constant. Then the remainder is p of a. Here's what that really means. Use synthetic division. Negative 1 is the divisor. This really, if you look here, comes from that. So it would be a factor of x plus 1. Now, if I rewrite those, I have 2, 6, 5. But notice that x with an exponent of 1 is missing, so I have to put a placeholder in. And 60, keeping the signs in front of them. Then I'm going to figure out, using synthetic division, what p of negative 1 would be had I implemented that into the equation. So if I put negative 1 in each of those x's and solved it, I would get the same answer. Negative 1 times 2 is negative 2. 6 minus 2 is 4. 4 times negative 1, negative 4, negative 9. Negative 9 times negative 1 is a positive 9. And negative 1 times 9 is a negative 9. So the answer is negative 69. What the remainder theorem says is that p of negative 1 is equal to negative 69. And you can check that by actually plugging negative 1 in for x. You should still end up with negative 69. Trying it again with this problem, p of 3. We're going to check to see what p of 3 is equal to. There's my first coefficient. Negative 2 is the second. There is no x squared, so we put a filler in, or a placeholder. There's a 1 and a negative 9. Drop the first coefficient. 3 times 1 is 3. That gives me a positive 1. 3 times 1 is 3 again. Gives me a positive 3. 3 times 3 is 9, which is 10. And 10 times 3 is 30. Negative 9 plus 30 is a positive 21. So what that means is that P of 3 equals 21. And again, you can check that by taking 3 and plugging it in for x and seeing if you get 21.